right, good morning and welcome back. Day 5. Today is the vector voyage activity. We're going to be looking at vectors and kind of examining this scenario where we are setting sail on a ship from Spain, traveling across the Atlantic Ocean. We're going to see how different vectors kind of influence our ship's position. Okay. Now, as we do this activity, make sure you are signed into Delta Math as you're watching this video. You can watch it through. You'll get points for just watching it and following along with me. Now, obviously, I can't see that you're following along, so kind of a check for that at the end. There will be, on the last example on the back here for part 3, I'm not going to finish the example all the way through. You'll just be asked to finish it and then answer what you got for where the ship ends up and how long it took. Okay, so some things to think about. You will be doing that towards the end. Make sure you're following along. It should not be that hard. Just follow along with me and we'll get through this. So if we look here, first thing we want to do here, we have our color key. Let's choose what colors we're going to use. And if you're doing this at home or in a different classroom, you don't have access to colored pencils, it's fine. You can use a pen. You can use a pattern if you want, like put dots or dashes. It really can be done even just all with straight pencil lines. It's just then you got to keep things straight, like which one is my, which vector represents what. Okay, so I'm going to go ahead and have color 1 be red. Let's see. We'll do color 2 in blue. We'll do color 3. Actually, let's do color 3 as purple. And color 4, we'll do this light blue. So, all right. So, if we look here, this first problem, part 1, it says your ship can sail 10 units per month. Okay, so starting from Spain and traveling west, bearing 270 degrees. I want to make a point about that. Okay, bearing 270 degrees, but it's west. So you don't need to mark this on here, but let's look at this, our compass rose, as we call it, up here. So oftentimes, 270 degrees west, I guess I don't know why I said oftentimes, but 270 degrees west, if we think about it, that doesn't really make sense with what we've normally done. So we, with our unit circle, have been starting here at 0 degrees. Here is 90 degrees. Here is 180 degrees. Here's 270. If we would finish it out, we're back to 360. Okay, that's how we do it with our unit circle. This is slightly different. Sometimes when direction gets involved, when there's application, you have to just think about what makes sense with the problem. Okay, so in this case, with direction, if I ask you guys to recite the 4 directions, I would guess 99% of you would start with north. Okay, and if we think about it, not only would you start with north, but I would guarantee that almost all of you would say east, then south, then west. Okay, that is just how we have learned the system, right? Never eat soggy waffles is what a lot of you say. Never ever sell weed. Never eat slimy worms. Whatever it is, it's always north, east, south, west. We work our way around clockwise, okay? So that's a little different than how we consider it on our unit circle, where we start on the right side at 0 and then work our way around counterclockwise. So the way this is oriented would be 0 right here, 90 to the east, 180 would be to the south, and that means 270 is to the west. So that's what it's talking about. We're just going to keep that in mind. It shouldn't really matter for the application of this problem. I think this is the only spot where it even talks about that, but I just want to make sure that you kind of understand that. Sometimes in story problems and word problems, the actual application of the math into the world isn't always going to be exactly like it was in the classroom, right? But we have to adapt. We have to kind of use it and go from there. So it says you can sail 10 units per month, starting from Spain and traveling west. Draw 1 vector for each month of traveling using color 1. Okay, so if we start here, and we're going to draw it out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1 month. And then I'm going to go ahead and put my arrow there. That represents 1 month has passed. Okay, now this was 1 month because we went 10 units. Let's do another month. So from that same spot where we ended, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we draw it there. That arrow represents the second month has passed. Okay, now we go for the third month. Once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then finish it out. I know it's not going to be a perfect month, but we finish it out, and it goes 1, 2, 3, 4, 5, 6, or it depends on if you want to go to that little point there, but either way, we make it to land partway through that fourth month. So it asks us down here, where will you make landfall? And it's kind of up to you on what you put here. One answer would just be United States. If you want to be more specific, let's see, what is that? That's around like Maryland, Virginia, somewhere around Washington, D.C. over there. It's not a perfect picture of the United States, but if you want, you can put one of those. Let's see, something like that. But I'm not super picky about this answer. But you hit the United States. And how many months will it take to reach land? If we think about it, so it's 1 month, 2 months, 3 months, and then this is 1, 2, 3, 4, 5, 6. So either 5 or 6 out of 10. So either like 3.5 or 3.6 months. Okay, and that's all there is to it. And that would be how we could map things out. If when you simply set sail, it was that easy. You just went out and it was 10 units per month, always consistent, always the same. Of course, in reality, that's not how it worked. And maybe in today's world, with modern technology, boats, I'm sure, are much more predictable. But a long time ago, when people sailed across the ocean, it wasn't quite that simple. There were a lot of things that would influence them, right? The wind, the water. If there was a storm, it could push them around this ocean. And their path wouldn't simply be a perfect horizontal line right across this map, okay? They would be zooming all over the place, okay? So as we look at part 2, it says, unfortunately, the wind does not always blow the way you want. Determine how the wind affects our travel. Let's include the wind vector, okay? So first, draw your ship vector, just like in part 1, using color 1. Okay, then it says, now at the end of the vector, add the wind vector using your color 2. Then draw your resulting vector using color 3. This will show where you end after the first month. Then do the same for the following months until you reach land. Remember, the wind changes, so make sure to add the correct vector for each month. So as you can see here, we have month 1, month 2, month 3, and month 4. Those are the different wind vectors, how we're going to represent it. So for this first month, once again, we start off, and we already have this one here, but if I was to draw it right here, I'll just draw it over the top. That's our first month in terms of the movement to the left. Okay, that's 10 units. Now, color 2 represents our wind. And for this first month, it is 2 units south. Okay, so 2 units south means I go down 2 units. South, we know, is straight down. Okay, and now I need to choose my third color, which I used purple for. And that's my resultant vector. That is where I get to. So we combine those two vectors together. Now, in reality, did our ship move left 10, then down 2? No, that wind was blowing throughout the month, but that was the end result of the wind. Okay, and our end result, our resultant vector here in purple, was right there. Okay, so now from that spot, we will once again go. So we're going to go left 10 again. So if we go left 10, we end up here. And then if we look back down, it says that month 2's wind vector was 4 units east and 4 units south. Okay, now 4 units east and 4 units south. We could do this as 2 vectors, or we can just do it as 1. So we could do 1, 2, 3, 4 units to the east, and then 1, 2, 3, 4 units south. I'm just going to do it as 1 vector. If you want, you could draw 2 vectors, a horizontal and a vertical one there, but I'm just going to do it as 1 vector, okay? And then we need to switch back to color 3, draw in that resultant vector, and this is where we end up. All right, so now from that point, now we'll go set sail again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we once again sailed 10. And now let's look month 3. It was 2 units west. Okay, so month 3 was 2 units west. We know west is to the left, so the wind helped us this month. 1, 2. And then it's kind of maybe a little hard to do, but our resultant vector is just going to be right on top of both of those. It'll be that whole distance from the red and the blue vector together. And then our final month here, from that spot, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we may hit land. Let's check. And there's no wind, so nothing that influenced us that month except just our movement to the left. And as you can see, I'm guessing most of you know, we hit landfall at Florida. Okay, so once again, we hit land in Florida. We could say the United States, or you can say Florida. And we are asking how long did it take us to reach land, and that took an entire 4 months that time. Oh, and the one thing I did not do that I still need to do is let's draw that resultant vector just so it's consistent. Now that time the resultant vector is the exact same, so it's kind of an unnecessary step, but that way that purple tracks kind of where we were at each month that passed. So how long did it take to reach land? 4 months. All right. So now go ahead and flip it over to the back, and on the back, I forgot to put a color key, so let's make sure we label as we read this, but it says, unfortunately, ocean currents affect boats too. Each month, you must also add a water current vector to find your actual final position. So just like in part 2, for each month, draw your ship vector in color 1. So let's go ahead. I'm going to draw that in red. Okay. Your wind vector is in color 2. That'll still be blue. And then there's also an ocean vector. What I mean by that is, like, what are the ocean currents doing? Is it flowing up, north? Is it flowing south, east, west, a combination? And so that's going to be our purple. Okay. And then use color 4, which I believe I had light blue on the front. So that's going to be my resultant vector. Okay, so it takes the sum of those 3 vectors. Okay, we'll do this for each each month until we hit land. So also keep in mind the wind and ocean vectors change each month. So let's start off with just straightforward our 10 units to the left. So once again, we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the left. Okay, now wind. Once again, just like on the front, that's 2 units to the south. Okay, so 2 units to the south, straight down, 1, 2. Okay, and then we need our ocean vector, which is also 2 units south. So 2 more units south, 1, 2. And as you can see then, our resulting vector gets us over here. And 1 month is done. Okay, now we move on to month 2. Okay, so month 2, once again, we want to start by going with our red vector. And I'll go ahead and stop for a second. Just keep the video rolling. I want you to see if you can map out where you think this will end up. Okay, so I'll just pause, just let the video roll, see if you can map out where month 2 will end up. So month 2, once again, remember to start with 10 units left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then we need to map our wind, okay, which is 4 units east and 4 units south. So 1, 2, 3, 4, down 1, 2, 3, 4. And then the final one is the ocean vector, okay, which here is 4 units west. So that's going to go 1, 2, 3, 4. And let's see, I did that in the wrong color, so let me fix that. We want to be consistent. The ocean vector, we've been using purple. So 1, 2, 3, 4. And then my resultant vector will be that light blue, and it will go to there. And the interesting thing about this is it looks like a straight line then. Now in reality, as these things blew, we were moving all over the place. But after the second month, we are right here, right above the A in Atlantic Ocean, the second A. So that's 2 months down. I want you guys to keep going. This is the end of the video. If you go to the next question here, so finish it up, keep graphing until you hit land, and then it will ask you where will you make landfall, and then how many months will it take to reach land. You don't need to put in a label, just give me a number. So like on the front side, it would have been 4, it would have been 3.6. The label will be there at the end for you already. But answer those 2 questions and then submit it. And then hopefully if you have fallen behind on any of the delta, today would be a day you could maybe have some time to catch up. So I hope you guys have a great day, and I'll talk to you later. Bye.